Good day again to everyone. Before we're going to start our lesson, now may I again encourage everyone who is watching this channel or this video to please subscribe and click the notification bell so that should there be a new lesson that is being posted, you will be notified. Now again, I just want to encourage you to please help also this channel as I do my part or as I share my part to all the students who is watching this video. Okay. Now our focus today is the slope of the tangent line and the curve, or shall we say the derivative as the slope of the tangent line. Okay. Now before we continue, now we just try to go over with some of the principle that we have already discussed. So it says in here, the derivative of a function f at x is defined to be the f prime of x is equal to the limit of f of x plus change of x minus f of x over change of x as your change of x is approaching 0. So, meaning to say, we have already stated this one, that this notation is actually the derivative which stands for the slope of the tangent line. Now, so that you will notice some of the notation for derivatives, this statement can be written into this form. Okay, f prime of x is equal to the limit of change of y over the change of x as your change of x is approaching 0. Or that can be written in the form of the limit of f of x plus change of x minus f of x over change of x as your change of x is approaching 0. Now, as we have said last time, that this is actually the slope of the tangent line. So that is equated to m. And another way of writing the derivative, or another way of the notation of the derivative, is d over dx. Okay, so this statement pertains to a single term, that is the word derivative. Okay, derivatives. Now, how are we going to apply these derivatives that we have in here? Definitely, when we are going to apply this one or illustrate this one, now may we consider one of the problem. So it says in here, find the slope of the tangent line to a function f of x is equal to the square root of x at a given point 1 and 1. Then after having now the slope of the tangent line, then name the equation of the tangent line. Now, before we're going to solve for this one, or have the slope of the tangent line, now I would like to illustrate first the curve. Okay, so when we are going to illustrate the curve, notice that this is actually what kind of function? This is actually, okay, square root function. So that I would like to encourage you to please graph first this function before we're going to tackle the slope of the tangent line. So that notice when we are going to graph this one, we have to define first the domain. Okay, so the domain of this square root function that we have in here is actually, okay, the domain are actually all real numbers. Okay, all real numbers except negative negative numbers. Okay, so that is the domain of this function. Okay, so meaning to say, after knowing the domain of the function, then we can assume now the value of x. Okay, so we can assume now the value of x that we have in here. So if the domain are all real numbers except negative numbers, then I might start my value of x. Okay, I will start the value of x by using the number 0. Okay, so if I have 0, 1, 2, 3, and 4, so that you will notice when we are going to graph this one, that is the same as, let's just try to make use of the one solution for the table. Okay, so if I have x to be 0, okay, f of 0 is equal to the square root of 0, will give you that is the same as 0. Okay, so meaning to say that is 0. Now another one is when we have f of 1, which is equal to the square root of 1, then it will give you that is the same as 1. So meaning this is the same as 1. Okay, so this is the same as 1. Now let's try to continue. So that if our x is 2, then f of 2 is equal to the square root of 2. Now what is the square root of 2? That is the same as 1.41. Okay, 1.41. Now what about if our x is 3? Now we can say that f of 3 is equal to the square root of 3 will give you 1.73. Okay, 1.73. And it will follow that if your x is 4, we say f of 4 is equal to the square root of 4 will give you 2. Okay, 2. Now notice I have in here now the values of the function. If I have in here the given determined values of x. Having said this one, we can now solve, or we can now illustrate the graph of the function f of x is equal to the square root of x. So if I have x which is 0, that is located at the point of origin. So meaning to say it is located in here. Okay, it is located in here. So that should I have 1, my f of x is also 1. So where is that located? Now that is located in here. I will use ruler so that I can have a very exact, more or less accurate drawing. Okay, so that if I have 2, now at least I have 1.41. So if this is 1.50, just below the 1.50, that could be 1.41. So that will be the 1.41, more or less it is located in here. Okay, so ayan. So if I have 3, the value of my y is 1.73. So if this is 1.5, in here at least more or less this is the location of 1.73. Okay, 1.73. And so where is that? The point is located in here. Okay, that is the location of the point. So that if I have shall we say that is the same as 4, the value of y is of course 2. So meaning the location is, we have in here the point. Okay, we have in here the point. So having said that one, having determined the location of the point, what we'll be doing is we're going now to connect. Okay, we're going to connect the points. So if I were to connect the points, so I have in here, I will make use of blue ball pen. Okay, or still green. We'll still make use of green. Okay, ayan. So that is the graph that we will be having. Okay, more or less that is the graph that we will be having. Now the point of tangency is actually located. Okay, so notice that find the slope of the tangent line, slope of the tangent line to a function f of x at point 1, 1. So which is, that is called to be now the point of tangency. So this is 1 and 1. Now we call this one to be the, what is that? Point of tangency. Okay, tangency. So that is the point of tangency. Now, of course, before we're going to continue looking into the line, we know that the line passes to this point. But before we're going to have that line, now we might as well compute first now the slope of the tangent line, so that at least when we are going to locate that tangent line, we can have a more accurate drawing. Okay, because we have the guide, which is the slope. Okay, now to look for the slope now of the tangent line, now we have to consider now our function. Okay, so our function in here is said to be f of x. Okay, and f of x is equal to the square root of x. So that using this one, the value of our f of x is actually this one. Okay, so meaning to say, when we are going to have the equation continuing that one, we say the limit. Okay, the limit as your change of x approaching 0 will have the square root. Okay, the square root of what? Change of your x is this one, x plus change of x. So x plus change of x minus f of x. What is your f of x? That is the same as minus the square root of x. Okay, over the change of x. Now notice that when we will be having a direct substitution, it will give you an undefined term. Okay, so that if it will give you an undefined term, then there must be no limit. But in here we have to do something in order for us to get the limit of the given problem. So what are we going to do? We have to make again the use of magic 1, or our multiplier is 1, which is defined to be the reciprocal of this one. So meaning to say, we are going to that is the same as rationalize the problem. So when we rationalize the limit, the opposite of this one will be the square root of x plus change of x. Okay, change of x, if that is subtraction, then this must be addition. So conjugate of this one must be positive. Okay, so yan. So of course, we have said that our multiplier is 1, so that is over the square root of x plus change of x. Okay, change of x plus the square root of x. So notice that what we will be doing in here is we're actually rationalizing the limit. Or notice when we rationalize, our multiplier is 1, but our 1 is defined to be the quotient of the square root of x plus change of x plus the square root of x over the same square root of x plus change of x plus the square root of x. Now notice that we have in here the difference, the product of the difference of two binomial. Okay, the product, it is actually the product of the difference and sum of two binomial, wherein it will give you a result. Okay, if we will be continuing that one, that is the same as the limit as your change of x approaching 0 will give you, that is the same as, okay, the square root of x plus change of x. Actually, that is raised to 2. Okay, definitely there is no middle term, but that is minus the square root of multiply x multiplied by x, the square root of x raised to 2. Now what about this one? Now we tend not to multiply first, so we might simplify immediately. So we just copy as product change of x multiplied by this binomial, the square root of x plus change of x, okay, plus the square root of x. Now notice that when we are going to continue that one, we have now this statement. Okay, we have now this statement, the limit as your change of x is approaching 0. Now what is the square root of this one? Okay, notice that I put it up above the bar so that I will not use the parentheses. So notice the square root is, what is that? That is x plus change of x. What is the square root of this one? Minus x. Okay, so what about in here? We'll copy the same. So that is change of x multiplied by the square root of x plus change of x, okay, plus the square root of x, okay, so plus the square root of x. And notice that when you notice this one, the x in here in the numerator are opposite, so this can be subtracted with this one and it will give you 0. Now what remains now is a change of x. Now you notice that after having now the result 0, our new numerator now will be change of x. So that if that is the change of x, we will be having now a statement saying the limit as your change of x is approaching 0, okay, our numerator now will be change of x, so that you notice our denominator change of x multiplied by the square root of x plus change of x, okay, plus the square root of x, okay. And so if you notice that we can cancel this one, change of x over the change of x. So what is now our new limit? Our new limit now is the limit as your change of x is approaching 0, we'll have now a result 1, okay, over the square root of x plus change of x, okay, plus the square root of x. Now what is the limit? Okay, so we can have now the substitution. So we will substitute the change of x in here, so that if we will substitute now, it will give you now a result which is the same as 1 over the square root of x plus change of x is 0 plus the square root of x. So in here now, we can have now that is the same as 1. How about this one? What is left? The square root of x, because that is 0, plus the square root of x. It will give you 2 the square root of x. So meaning, as we have in here, the slope now is 1 over 2 the square root of x. So that is the slope of the given function in here. Okay, f of x is equal to x raised to 2. But it says in here, what is the slope of the tangent line when we will be considering a tangent point of tangency? So meaning to say, we can have now the slope considering the point of tangency, which is 1 and 1. Okay, having said that one, our slope now is the same as we substitute your x in here. So what is your x? That is 1. So 1 the square root of 1. What is that? 1 multiplied by 2. And so our slope now is actually 1/2. Okay, so meaning when we are going to have this 1/2, that is the slope of the tangent line, at a certain point, which is point of tangency. Where is that located? Now allow me to make use of our illustration a while ago. Okay, so our illustration a while ago. So we have in here. Okay, we have in here. So this is our the location of this the slope of this one is the slope of the tangent line, and we have said that the slope of the tangent line is also the slope of the curve to that certain point, which is point of tangency. So how do we create our tangent line now in here? So when we are going to create our tangent line, let's consider this one to be our point of tangency. We count. Okay, we count upward. Okay, because as what we have said, our slope is change of y over the change of x. What is our change of y? 1. So from this point, we count 1 unit. So more or less, it says here in here. So after that one, change of y, change of x, we count 2 units. Okay, along the x-axis. So 2 units from this one. 1 and 2. Okay, so meaning to say, our point in here is located. So with that, we can draw now the point of tangency that we are talking. Okay, so we have in here now our point of tangency. You try to look at how we draw the tangent line. Okay, so our tangent line now is we have in here. Notice that our tangent line now is actually this one. Okay, so that is our tangent line. So our point of tangency is in here. Okay, that is in here. So this is, let's try to label this one to be our tangent line. Okay, so let's label this one to be tangent line. Okay, that is the tangent line that we have. So that is the drawing. Now, after knowing now the slope, we are going to look for the equation of the tangent line, which is the next problem. So it says in here in the problem, name the equation of the tangent line, or it says in here in the problem, name the equation of the tangent line. So that when we name the equation of the tangent line, we have to recall our basic equation regarding the equation of the line. Okay, so what is the one of the basic equation of the line? We have the form point slope form. So what is the point slope form? Okay, point slope form. So how is that? The point slope form is actually y minus y1, which is equal to the slope multiplied by the quantity x minus x1. Now, you have to remember that what we are talking in here now, y sub 1 and x sub 1, is actually the coordinates. Okay, the coordinates of point of tangency. So let's try to write it in here. Okay, so point to x sub 1 and y sub 1 is actually the point of tangency. Okay, point of tangency. Okay, so notice that we can have now the equation of the line. Why? Because we have the point of tangency. What is the point of tangency? We have 1 and 1. Now what is our m? Our m now, which was computed, is the same as 1/2. Okay, so using these elements, okay, we can make use now of this form to look for the equation of the tangent line. So y, we can just replace y. Okay, y minus what is our point of tangency, which is y, that is minus 1. Okay, minus 1, which is equal to m. What is our m? Our m now is the one that is being computed, that is 1/2. Okay, multiplied by the quantity x minus what is your x sub 1. So what is your x sub 1? That is the same as 1. So we have in here now the form, point slope form. Now after replacing now or substituting the point slope form, that's the time we're going to manipulate, putting them now in the linear form. Okay, so that is the same as let's try to transfer that one. Okay, let's try to distribute. So we have in here 1/2 x multiplied in here, that is the same as negative 1/2. Okay, negative 1/2, and of course that is the same as y minus 1. Okay, having said that one, isolate y, it will give you now 1/2 x minus 1/2 plus, okay, plus 1. Now it will give you now 1/2 x, 1/2 minus 1/2 plus 1 it will give you plus, okay, it will give you plus 1 1/2. So meaning to say, this is already the equation, okay? Okay, what is that? Equation of the tangent line. Okay, so that is the equation of the tangent line. Now, having said that one to be the equation of the tangent line, now we can now, of course, use this one to label our tangent line. So let's label our tangent line. So by having this one, so the name of this tangent line that we have in here, y is equal to 1/2 x plus 1/2. Okay, so again, thank you for watching, and I hope you understand the problem. Allow me again to have the number 2. Okay, allow me to at least have the number 2.